Okay. Just scroll down. So what are the different features in the APB specification you have gone through? What are the what is the main functionality in the APB protocol which everyone should know? If anyone say, do you know about the APB?
And APP protocol for every transfer it takes two cycles, and
Okay.
and there will be three states in it. One is idle
Okay.
state where everything will be on the zeroth position. I mean reset state. After that, uh, it will go through the setup phase where my I need to give valid right address, right data, and
Hmm.
I, if I want to write the data to the slave, then I need to keep my P-write signal active. If I want
Hmm.
to read data from the slave, I need to keep my P-write signal active. If
Okay.
all are done correctly in setup phase, then uh, I will move into the access state where my P enable will be active based on the P ready signal from the slave. If slave
Okay.
is ready to be accept the data, it will be active remain. At that time, my data will be write
Okay.
into the slave or read from the slave.
Okay. Great.
That that is without state. I mean without wait. Man.
Wait
After
state.
that,
Okay. Okay.
without wait.
Just hold on. We'll hear from some. I understood that you have gone through and you have good idea. Let's give chance to some others also. Just present your screen. We will.
Okay, I will mute myself.
Yeah. Vinay, can you try from your side? What are the wait states in the APP protocol? And what do you understand by the different phases in the APP protocol?
Hi, ma'am.
Yes.
Uh,
Have you gone through the APB spec?
Actually, no, ma'am. This document haven't received.
You haven't received?
No, ma'am.
So you would have asked, right, when I have said that by tomorrow's session, everyone go through it. So you should have asked like which document I should refer.
Uh, I don't know, ma'am, about that document you have shared in the group.
Fine. I'm resharing it.
Yes, ma'am.
You go through it by the time everyone go through. Or now Manideep has explained, right? So based on that reference also, you can tell what you understand, right? Okay, that's fine. Maybe
Yes,
it's
ma'am.
stuff. I have shared it. You go through it. At the end, I'll ask you. Because I'm insisting every one of you to go through it because that is when you will understand what we are trying to do, right? So that's why please go through it. It's for you guys better understanding only I'm telling. Okay, what about others? Devika, have you gone through it?
Um,
Hello?
so what, yes, am I audible?
Yes, yes. Very clear.
Uh, yeah. So I have undergone read the document once.
Mm-hmm.
But I don't know whether thoroughly I'm able to explain. But I understood.
In that case, you can just present your screen and just you can see it and then only tell me. It's not like in one read I expect you to know everything, but whatever you have understood now, that in brief
Yeah.
you can tell me. Okay?
Yeah. So with the same document, shall I tell what I have understood?
You can also present at your end from the same document so that it will be easy for you if you have forgot anything. So you can refer it and tell it, right? That's fine. You can present your screen with this document, APP protocol.
Hello.
Hello?
Am I audible?
Yeah, you're audible.
Yeah. So it is a low-cost interface protocol which is optimized for a minimal power consumption and reduced interface complexity, and it is a synchronized protocol, so which takes 2 cycles to complete. So, and here in ABP we have various signals for
Two
clock
cycles
input.
to complete, in the sense what happens exactly in the two clock cycles?
So it has actually 3 states. First
Okay.
one, first one is the ideal state, which is a default state for this ABP interface. And
Mm-hmm.
then in the setup phase state, it transfers the required or select signals. That is the
Okay.
select have a signal like P as P select X if it is
Okay.
1,
Okay.
and then
What
P.
is P select means basically?
So it is a signal which we will be using in APB protocol.
Okay.
So it is a requester. So this generates a signal for each. It indicates whether it is a selected signal data transfer is required or it is completed or not.
Can we call it as a slave signal?
Yeah,
Means this. Okay. Mhm. So
yeah,
we can say that if the P select is high, the slave is ready to accept the data from the master. If
yes,
not, P select is low, it means that slave is not yet ready for the data from the master. So
yes,
without P select, can we transfer the data from the master to the slave?
no,
Okay,
no.
fine. Yeah, go ahead.
Okay, and then it moves to the access state
Mhm.
if that is done. So in the access again, it will check for the P select if it is 1, and
Who is
here
presenting the screen?
the P
Manidip,
enable.
right? So can
And
you
I have
just go
stopped.
to that? You have stopped it. Okay.
Should I share again?
So, no, no, no. Devika, can you share the screen? And regarding
Yeah,
APB protocol, can you share?
yeah,
And go to the part where you are explaining the access space and all, right? That you will explain.
yeah, yeah.
Everyone have the document handy, because I can ask anyone, right? So just not to waste the time, just keep your document handy. She has left the meeting. Okay, meanwhile, anyone else would like to try? Pramod, would you like to explain what you have understood related to the APB protocol? Pramod, are you there? Pawan, would you like to try?
Sorry?
Would you like to explain what you have understood regarding the APB protocol?
Yeah, okay. So, okay. Do I need to share? Because
Yeah, it's good if you share, if it's possible.
I'm not sure. Can you please check once?
Yeah, it's loading.
Okay. No, I think I can't able to share because I joined through tab.
Okay.
Maybe someone or you can only share. I will tell you.
Okay. Wait, let me share. You just start it, I will share.
Yeah, I stopped.
I mean to say, you just start with the explanation, I will show.
Okay. Yeah, so like APB is like on-chip protocol.
Okay.
This we use in order to establish a communication between two peripherals. Say, like if you have like very less bandwidth of data, so then we can choose this, where one side acts as a bridge, another side acts as a slave. So again, as many of told, like it has three states: idle, setup, and access. So in idle, it is starting phase. If, when master want to send some transactions, then it will select a slave. So that's what setup phase. And to that, slave will respond by asserting a P ready. That happens in access. So if slave is not ready to accept the invitations, then it can wait. It can tell to master to wait. So that's the two cycle response. Apart from this, I think that's it, right?
Okay, so what is the pipelining? What are the disadvantages in the APB protocol, which we are
Ye-
finding in the other advanced protocols?
Okay, so like it's non-pipelining because so like if some transaction is not happening, it needs to wait till the transaction to complete. So
Yeah.
both master, right? So it can't able to issue another transaction. So that's the drawback.
Okay. What about others? So how is it being possible in other protocols, but not here? When do we prefer APB protocols in what applications?
That's what like less bandwidth applications, right? Low
Yeah.
bandwidth application.
Okay. So in APB protocol, you mean to say there is no pipelining concept. That's why we are not able to fetch the higher bandwidth applications, right? Hello.
I'm not sure about this.
Okay.
I think uh, bandwidth concept and this pipelining is entirely different, I guess.
Okay. So through pipelining, what do we achieve? High
So
performance?
pipelining, if you say you are sending as a master, you are sending one transaction to a slave. You can't able to send one more transaction if pipelining is not there, right? So you need to wait till that existing transaction has to complete.
Yes.
Yeah.
So basically, you mean to say through pipelining, we achieve more performance, basically, right?
Yeah,
So the
kind of.
performance is nothing but the bandwidth, right? So that is the entire idea, right? So for the low speed protocols, means we have less bandwidth. That's why the APB protocol doesn't support the pipelining concept. That's why it is taking 2 clock cycles, like how Devika mentioned, like 2 clock cycles it takes to do a transfer. So once the address is sent, then after the data is sent, like that is done. But if you see in the advanced protocols like AXI, their pipelining concept is introduced over there in order to support the high speed protocols, and it also supports pipelining through which the performance increases, and it is allowed to cover the more bandwidth also. So this is the basic idea. And we have one more moderate protocol also, that is called AHB protocol. These all protocols are belonging to the AMBA family itself. So and the AXI protocol will have the high performance and high features, because the pipelining concept, which is supported by the AXI, is not supported by the APB. And AHB is moderate because it has little more enhancements than APB, which is not there in the APB, the APB, but AHB has some more enhancements. That's why it is preferred for the moderate speed protocols. Okay.
But
So now,
sorry, but isn't the bandwidth is depending upon the data width that supporting?
that is also there. The data width will be there. Definitely, you can have in AXI the more data width options, right? Than with compared to the APB and AHB, right? So that will
Okay.
also be the one of the factors, definitely.
Okay, I understood in that case. Sorry.
Yeah. So performance wise is the basic thing. Performance means what? How do you measure the performance? Any one of you? In the lesser time, you're sending more data. It means that the performance is high, isn't it?
Yeah, correct.
So if the performance is high, the power consumption is also high. So any one of the things you have to compromise, either the power consumption we have to compromise, or we have to compromise on the performance, or we have to compromise on the number of signals which we are using. So more number of signals, more number of features, everything will be there. So based on the requirement, based on your application, we have to choose a respective or appropriate protocol, so that it will support, if for suppose my application has a power consumption as the major constraint, then major constraint in the sense, for me, even though the power consumption is more, that is fine, but I need only more features. In that case, I will choose AXI. For me, if the power consumption is a constraint, like I don't want to use more power consumption, but I just need just low speed. In that case, you will prefer APB. Like that, any one of the parameter you have to compromise, and based on the different requirements of your particular application, you have to choose a protocol. So this is the basic idea we need to have. So which protocol will have to be used in which state. Okay. So now,
Like,
yeah.
like I have one more small doubt.
Okay.
Suppose say I have like one master and one slave, which is both APB and AXI capable. Okay. So and
Okay.
that its support is 32-bit only, the data bus one. So can you like explain how bandwidth will how we will
Can
achieve
you
higher
just
bandwidth?
repeat the question once again?
Okay, so I have like one master and slave. Okay, so which both will be both APB and AXI capable. Okay,
Okay.
master and slave.
Hmm.
Yeah, I'm trying to understand. So the
Okay.
thing is, both APB and AXI can use 32-bit only, not more than that, for my
Okay.
master and slave. So I wanted to know like how we can increase the bandwidth by using AXI, just by using AXI, because
See,
both the APB and AXI was 32 bits only, right?
yeah. See, that's what I told when you said about the bandwidth. It is like, how will you perform? How will you means use that metric to say that the bandwidth is increasing? Then both are same. Then the next thing is what the performance, right? So the performance, how you will increase is, you will go with the AXI only instead of APB if you want to increase more performance, because in AXI within the less time you can send more number of 32-bit data, right? Means in the from the same APB, if I am trying to share the two 32-bit data in some time, in the within the same time through AXI, I can perform 5 to 10 data transfer. Which is why then if the performance is your main constraint, then you will choose AXI. Any master and slave, basically first you will decide which protocol you will use. Based on that, you will use your transaction class, everything in driver, protocol logic, everything you will do. Based on that, your master and slave will behave. So first you will decide which protocol you have to use. Then you will instruct your master or slave to behave in that particular way. So what is a protocol means is nothing but a set of rules. So you behave this way, you behave this way. You are providing, you have some set of rules. Based on that, your protocol has to behave. Your protocol is nothing but master and slave have to behave in that manner. So this is how you will understand. So that's why the first protocol has to be decided. Then you can protocol, how will you decide is based on your idea, whether the bandwidth or the performance. Based on all those things, you have to decide a protocol. Got it?
Okay. So in this case, bandwidth will be same, right?
Yeah, bandwidth will be same. The performance will matter when it comes to the comparison.
Okay. Okay. Got it.
Yeah.
Yeah. Thanks.
So anyone else, how the P-ready signal works and how the slave behaves, and anyone can explain what are the different wait states? Means the write transfer with wait states, or retransfer with wait states, or without wait states. How it differs from both of those? Hello, I think I should only unmute someone and ask. Devika, now you are able to interact, right? You said you were unable to join. If you guys would have gone through the protocol spec, it wouldn't be this late. Everyone would have unmuted by yourself and would have responded, right? Then the things would become easy and we would have gone forward. Now it's
So
the
you're
time
asking
is,
something?
yes. Am I audible to you guys?
Yeah. So
Yeah.
may I
I'm
know what's
asking like the question is how the transfer with wait states happen and transfer without wait states happen.
yeah, that is with respect to P ready, right? If slave is
Yeah,
not,
yeah.
if slave is not ready, so it can
Hmm.
assert P ready, right? It can extend the P ready to assert in the next cycle.
Yeah, yeah. I want to hear from others also so that it will be easy
Oh,
for
okay.
me to
Sorry then.
explain actually. That's fine. I'm just trying to know from others also.
I haven't understood about the periodic signal with wave states. That can you
Okay.
explain?
Yeah, yeah. Let me represent my screen. I'm unable to. Are you able to see my screen?
Yeah, it's only.
Just scroll it down. Something is wrong. Okay, any one of you just present your screen. Okay, I'm able to. Yeah. See, what you didn't understand with the weight states and without weight states, right?
With wave states, I haven't understood, ma'am. Like when the periodic
Well,
signal will be low.
okay, okay. See, I will explain you in simple. Like, it's same for both read transfer and write transfer. Just that you all know, right? Write transfer means the P write signal should be high. then only our data will be, the write address will be valid and the write data will be valid. Otherwise, when the P write signal is low, then we are having a read transfer. Means the read address, the same address we have, we will be having the PR data. Usually in some of the protocols, we have different address, like write address, read address, that way. In this protocol, we have only single variable called P address, which is using for both write and read address. And we also have a P write signal, a single signal. That's why when it is high, it is a write transfer. When it is low, it is a low read transfer. So this way the entire mechanism work, right? And when the P enable is high, and that point only the transfer is valid. So for any transfer to happen, our P select should be high and the P enable should be high. Then only the data transfer can happen. Okay. So here what we are trying to do is, without wait states is nothing but basically our slave is saying that I am ready to take the data from the master. Even before the data has come, if the P ready is high, it means the master need not wait for the slave to trigger the P ready, right? So it means that there is no wait state. Immediately the data will be accepted by the slave. But if it is with wait state, it means that the slave is not ready yet to accept the data. The slave is there. The P select is high, in the sense the slave is enabled, but it is trying it because there are many things to be done in the entire subsystem, right? If suppose that slave is serving some other master, and in any of those cases, and it is not ready for suppose, in that case, it will make the master to wait in order to make it ready to accept the data transfer. In that case, the P ready signal will be low till some instance. At some instance, the P ready will go high. Even though the master has sent the data, as P ready is not high, the slave is unable to accept the data. So how many number of states in the sense how many number of clock cycles it is waiting to accept the data, though those are nothing but your wait states. For example, here how many wait states we have? Can anyone tell just by examining the waveform?
Yeah, one wait state.
Who was that?
My Manideep,
Oh, okay. So here how many wait states we have?
0, ma'am. It is
Yeah,
when enable
means
is
when the data is there, it always examines at the posit. At this posit, if you see here this posit, everything is in the reset condition. At this posit, if you see, there is nothing you will see even here also, because this P address has come, but after this clockade posit, right? So this will be reflected at the T2. At the T1, everything is as usual. Okay. So when you see at the T2 you will find the address change has come, and the P select signal also is come. So this is our setup phase basically. So till there it was an ideal phase, and after that when the PR data has been sent and the P ready signal this will be sampled at T3 clock edge, because even at the T2 it is not yet arrived. Okay, so at T3 it has been arrived. So data is also arrived, P ready is also arrived at T3. So it means 0 wait states. And the same thing if you observe in the with wait states, that is PR data, the P ready signal is high at which clock cycle, that is T5. So the data has come here, right? The data transfer has already started here, and the data 1 is here. The address 1 has come long back. Here itself, at the T2 itself, we got the address. So it means here whatever is happening is the with wait states. The same thing you will observe in the write transfer also. With wait states here, the data 1 has already come here, and we are trying to see the P ready signal high here. So it means it is waiting. These are nothing but the wait states. Okay. Is it clear now what is wait states and without wait states?
yeah, it's clear, ma'am. When we have multiple masters and a single slave, then
I said that is an application. It could be an application. For any of the reason, the P ready might be low. Or you are driving such a, here in our case, what will we do? If you want to try that scenario, you will drive the P ready signal low for some cycles, and then you will try, right? In the same way, for different application, in any of the application, it could be the scenario, then it will have the wait states in real time, I said. Okay. But the main logic you have to understand is the slave is not ready as soon as the data has come. It is being arrived after 2 to 3 clock cycles. Those 3 clock cycles which you are waiting are nothing but the wait states.
Okay, ma'am.
Okay. So Ankit, are you clear with the APB protocol?
Yes, but I need to go through the documentation thoroughly.
Please go through it, then only we can start with the
Yeah.
session with confidence. And we have already shared one video also, right? So if you don't understand from the document, even through the video, you can grab it. Okay. So
Sure.
please go through it. Yeah. Pramod, what about you? Pramod, are you there? Or yes, left the meeting, I guess. Pramod, you are not audible. Who else left? Srinivas, have you understood the APB protocol? Okay, fine. Then we will move with, if anyone have any queries related to the protocol understanding, you guys can ask me and I can explain.
Ma'am, that last 4 signals, ma'am. P user attribute, I mean, user
Actually,
attribute
those are
request.
not important. You can ignore those actually, P user or that. Means
Okay.
those are the user defined signals, which is not necessary for now.
Okay.
You guys can focus on the other signals.
Will we implement key protection signal in our
Mostly
workshop?
no, because first we have to understand the entire UVM flow, all that, right? This is basically for the UVM workshop. We're trying to take a protocol so that it will be easy for us to understand and analyze. So we will not cover the protection feature on that. But you
Okay.
can try at your own, and that would be great. And if you have any queries, you can ask me.
Okay.
Yeah. So any one of you is using the ADA playground and try the codes in the SystemVerilog or anything.
Yes, ma'am.
Okay, so in that case, what we will do is, what I'm thinking is, we will divide into teams. In the EDA tool, we will try to start the coding tomorrow. We will first code the skeletal. So any one of you, any two members will present the screen, and half of this will be coded. Other team members has to guide him what should be coded. If that interactive way, if we do, then only it's interesting. If no one of you mute yourself, doesn't do anything, it doesn't work out. The one who is trying to participate, they will get the knowledge. If and others are not responding, there is no problem. The one who is responding, with them only, I'll make them code everything from scratch, and that will be great exposure for them only. So Pavan, would you like to code tomorrow the skeletal part for the APB protocol?
I mean, I exactly didn't understand like skeletal part of like what all the components.
Skeletal part in the sense that all the components, we will create a test bench and we will code all, we will only code, for example, driver. We will not implement any functionality of the APB specific protocol, but we will just create the driver component, everything registering in the factory, everything, all that we will do. And we will try to print the topology and make sure that our test bench has no errors. So this way we need to code. So half of things you can code and half of things Manideep can code, and then you can merge the entire test bench, and then we will run the test bench and we will see that we are free with the test bench errors.
But
Okay, and yeah,
not sure. Okay. Yeah.
not sure in the sense.
I'm not sure in the sense like you do have some calls at that time. That's what.
Oh, okay, fine.
Yeah.
If you
So
guys are not ready to
isn't it
do
like
that way, I will only have to code and I will show, but that doesn't give that feeling like how you guys code. That's why I said if it is not feasible, I'll do it. I'll present the screen and I'll do the coding part and I'll let you guys know like how it works. So I would like to hear from you guys like how do we do.
yeah, I think that's great because you can only code in parallel. We'll also try.
Yeah, fine. Then we will go that way. So today we will discuss about the interface. We haven't discussed like how the interface coding will be, and no one got any query like in this entire things in this class based environment, right? So how do we connect our test bench with the DUT? Is it okay to connect the with the same interface? It is possible. So this kind of doubts has anyone has got? Fine. First, let's see what's an interface. So anyone of you know what is an interface? Respond guys, because in SystemVerilog you would have already gone through what is interface, right?
Interface is used to connect DUT with test bench.
Okay.
Basically, a collection of signals.
Okay. Others? What else do we have in interface? What are these clocking blocks? Why do we need this clocking blocks? Why do we need this mod board?
Locking
So,
blocks are used to synchronize signals, like when
okay.
off. I mean, at what stage I need to. I mean, at what time I need to drive the inputs and
Hmm.
uh, out, um, that one outputs we need to check them out. I mean, at,
Okay, fine. Basically, like how the interface is nothing but a group of signals that are in a bunch or connected as a part of an interface from the DUT to the test bench. So all those signals, this interface encapsulate all the signals through which we connect our DUT to the test bench with this interface signals, right? So now we have different things in our interface. That is, for example, mod port is nothing but it gives the direction of the particular signals which are there in the interface. So whether it is an input or whether it is an output, it decides by the different mod ports. And the clocking block is nothing but, as Manideep said, it's related to the synchronization basically. So for example, we have some race conditions, all this, right? So we have got the solutions in the system Verilog. In Verilog, we got some solution like non-blocking assignment, like because of the different regions in the Verilog, the non-blocking things will be assigned in one region and evaluated in some other region. Through this, some of the race condition things we can resolve. In system Verilog, how do we resolve this? Through one thing is a program block, the other thing is also a clocking block. So basically, it is trying to give us a proper synchronization, having the input skew and output skews also. So anyone can tell me what is the input skew and what is the output skew? So with this input skew is nothing but based on the input skew, after so many clock cycle, after so many instances, the input will be derived. And if you whatever you provide the output skew, right, after that many it will sample the outputs. So this is basically the input skew and output skew, which we all learn about this interface in the SystemVerilog. So we all know that we have an interface, all this, but how do we connect a class-based environment and the the DUT, which is a static environment? These are entirely two different words. How do we connect them using an interface? Is it feasible to connect through the simple interface?
By using virtual interface, we can connect.
Yes, we use a virtual interface because it is not feasible to connect a static environment and the dynamic environment through an interface. We use a virtual interface. So we will go through this concepts because this is only thing that is left out from any of the coding part which we haven't covered, other than the config DB and the advanced concepts. So all the basic concepts which are required to code related to the APP protocol, it is covered. So let's go through the virtual interface also. And then we will go through the codes to understand how the virtual interface has been used in our test bench environment. So the device under test is, you all know what is DUT. Also, we typically, like usually we use a simple interface to connect your test bench and the DUT, right? Using the interface. But if you see, if it's a virtual interface, how it works, and also, as I said already, the DUT and test bench totally belong to the different SystemVerilog instance worlds. Our DUT is a static component, but our test bench is entirely class-based test cases, right? Means you will have driver, test, everything is based on class environment. So these two are a different entities, different backgrounds, so they cannot be connected through a simple interface. In that case, what we are trying to do is we are taking something called virtual interface, which will point to the interface. It will just point to the interface. So through that, indirectly we are connecting through interface the test bench and DUT. Right. So in the test bench, we'll have our virtual interface and that will point to the interface, and the interface is connected to the DUT. So we always say that we drive the driver will drive the data to the DUT through the interface. How do you say through the interface, right? So this virtual interface, and if you see in the code also, if you observe in the driver code, how do we mention is like, there is the driver code. Yeah, here. If you see this virtual interface we are using, how there's a virtual interface we are using is we are writing virtual, and then this is nothing but the interface name, actual interface name, right? Through this actual interface name is RAM if. So that is what we are using. Dot the mod port which we have. For example, this is the driver, right? So in interface, we would have mentioned some mod port, right? So for the driver. So that mod port you are pointing in. So virtual interface dot mod port, and you are giving an instance call for the virtual interface. You are giving some instance called VIF. So going forward, in order to use the interface directly through virtual interface, we are pointing it through the keyword called here VIF. This could be any of the things. Here we have given it is VIF. Okay. So the VIF dot WDR, this is the clocking block. Using that, you are trying to access a signal called reset, and this request dot reset means you already know from the transaction we will be sending to the driver, right? So the request dot reset. So this is how the driver works. And if you want to give any delays, instead of giving the hard coded delay like #2, #0, #1, instead you can directly use a VIF dot write driver clocking block. This is the more recommended way to give the delays in the driver or the monitor. Okay, using that particular clocking block. If it is a driver clocking block, you have to use this. If it is a monitor clocking block, you have to use the particular monitor clocking block instance, and you have to point it to the virtual interface. So now if you give here monitor clocking block, it will definitely give an error, right? Because inside this interface, inside the interface, we have the mod port. Inside mod port, you have given this clocking block. So when you in the driver, if you use a monitor mod port, most of the times people by mistakenly give the monitor mod port instead of driver mod port. Instead of driver mod port, they give monitor mod port. It will definitely give us an error because inside this mod port we have taken only the driver clocking block, right? So this has the access only to this, not to all of this. That's why it will give us an error. So if you encounter such kind of errors, you just go and see in interface how it is. So based on that, you have to change the appropriate clocking block. Okay. So now let's go to the that's what is mentioned here. Like using a virtual interface, a reference or a handle to the interface is instance, the test bench can access the tasks, functions, ports, and internal variables of the SystemVerilog interface. In interface, whatever you mention. Here we have mentioned mod ports and clocking blocks. If you have some tasks, if you have some functions in interface or anything, some internal variables you have taken in your interface, everything can be accessed through this virtual interface, which is pointing to the actual interface. Okay. So we all know, like through interface only, our driver will drive the data to the DUT, and the monitor will the sample the data from the DUT also through the interface. So in wherever you want to access from DUT test bench communication, indirectly you are trying to achieve through the virtual interface. So this is one of the basic and important concept everyone should know. Anyone who is interviewing you might ask you regarding this, like what is this? So anyone can ask you this kind of questions related in your interview. Why do we need virtual interface? What is the significance of virtual interface? Why we have chosen virtual interface? Was not possible through the actual interface? So how the virtual interface is connected to the actual interface? So all these things might be asked. So just note it down. So sometimes if the virtual interface approach cannot be used, in that case there are something like concrete classes and all can be used, but most of the times that is very advanced thing. So for now you can know that through virtual interface only it is recommended to do the test bench and DUT communication. Okay. So whatever the approach you use, that is not the matter. The communication between the test bench and DUT should be happen, and the information should be passed from the test bench to the DUT in whatever way you do. But this is the best approach which everyone follow basically using the virtual interface. So is everyone understood or anyone have any queries? Hello?
Understood.
Yeah. If any doubts, just ask me. We will halt and discuss. So the other thing is, while using the virtual interfaces, how do you pass this virtual interface from the higher hierarchy component to the lower hierarchy component is using the config DB. So whatever virtual interface you want to pass to other, like how now we are using it in the driver, right? How do we use it when you are passing that virtual interface from the top level to your respective component through the, either you can do it like this. First you have to set from the top and you can retrieve from the agent, and again you can from the agent you can set and you can retrieve from the driver, or directly from the top you can set and you can retrieve from the driver. So let us see in our way, our case, how did we do it. See, if you see here using the config DB, I am providing this virtual RAM if interface. I am setting it here and I will retrieve the same at the driver or agent. Let's see. Right agent. Yeah, we are doing it in the right agent. Inside right agent, what we are doing, we are retrieving the same thing. We have to just get it and you have to get this VIF. So you are passing the virtual interface from the one top level component, from the higher hierarchy level component to the lower level of the hierarchy. So that is what is showed in this pictorial representation also. Is it clear, guys?
Ma'am, can you please tell the basic difference between virtual interface and interface if someone asks?
Yeah, the basic difference is that the interface, the normal interface is an actual interface. Here also we use the actual interface only, but here when there is a purpose, like when we want, here the communication between the entire dynamic world to the static world. So dynamic world means, you know, right, what is dynamic? So all the class-based environment is a dynamic entity. But our DUT is a static entity because it is enclosed in a module, right? So it is a static entity. So when the dynamic entity wants to communicate with the static entity, it is with simple interface, it cannot. So what we are trying to do is we are creating a virtual interface which is pointing to the actual interface through the instance of the virtual interface, which is pointing to the actual interface. We are indirectly doing the communication between the DUT and the test bench, which we can achieve through the virtual interface. If you explain this much, it is more than enough.
Okay, ma'am. Thank you, ma'am.
Yeah. So, and then how the communication is between the DUT and the test bench, how through, like how we showed in the code, right, through agent we are passing. The same thing is represented in the pictorial representation. You guys can just go through it. Ma'am, can you please explain again how it is passed from the higher level component to the lower level? So first, for now, we don't know the concept of config DB and all, right? So that's why you might not know it, but you can understand how we are passing the interface from higher level component to the lower level component is using a config DB. So how to do that is in the top level where you are setting the virtual interface now. That is here. For the config DB, you are giving your virtual interface. Then we are virtual and you are declaring your actual interface as a virtual here. And then you are setting it, this config DB. The same thing we need to retrieve it at your desired level, whether you want to do it at the agent, whether you want to do it at the driver, whether you want to do it at the monitor. It's up to you. Based on your requirement, you can do it. So what are these arguments? What this argument signifies, everything we will go through in the config DB lecture. Okay. Someone is joining the class just after the session is about to end. Fine. So this is all about the interface, virtual interface, and we have also gone through the APB protocol specification today, like what is APB protocol, in what, how do we decide which protocol has to be chosen, that we have discussed, and we have discussed what are the advantages which are there with the other protocols which are not present in the APB protocol. So, and what are the different features, like what are the wait states in APB protocol we have discussed, what are not without wait states, how it works, and what is the significance of P select signal, P enable signal, P write signal, all these things we have gone through today. So before winding it up, I would like to ask some questions to you guys to understand how well you have grabbed the previous concepts. For example, can anyone explain me the UVM test flow? I'm expecting a proper answer because we have already discussed it multiple times. So I would like to know, can anyone explain me what is the UVM test flow? From where exactly it starts, how the which component gets created, and how the other phases get triggered or invoked. All these things I would like to listen. Any one of you.
Hello.
Yes.
Hello. Am
Other
I
than
audible, ma'am?
yeah, you are audible, but I would like to hear from other people also. You are already, I know that you know about it. Vinay, would you like to answer? Now you would have gone through the previous recorded sessions, right? Praneeth, would you like to answer? Am I audible, guys?
Hello?
Yes.
Can you repeat the question?
Can you just tell me what is a UVM test flow?
Means test bench hierarchy.
Not test bench hierarchy, the flow, like from where the execution starts and how the different phases get triggered, all this basically.
I don't know.
Have you gone through the previous sessions where I have explained the UVM test flow, right? If you want, I'll show the pictorial representation. Through that, you guys can tell me. So this is the UVM test flow. If anyone asks you, you should be able to explain this. Now, can you explain?
I have to go through the recording once.
Okay. It's too late, guys. Please go through the recordings before we start the practical session, right? At least we should be knowing what the theoretical. That's why first we do the theoretical and the practical, right? If you want, I will give one more day time. You guys can go through, but just go through. Okay, please, every one of you go through today. By the time we meet tomorrow, make sure that all recordings are being heard by you at least once and get your concepts clear, each and everything, so that it will be easy for you guys itself. Because there is no point of attending workshop if you haven't understood the entire flow, all this, right? Okay.
Hello,
Yes.
ma'am. Am I audible?
Yes, you are audible.
Ma'am, so I want to tell that UVM test flow.
Yeah.
So first,
Go ahead.
first we will test case creation. So in that test cases, we define by extending from base test class, and after that, sequence creation, like we are creating the sequences by defining the
See,
stimulus for
this
test
is
class.
all
And
this is all fine, but before that, the test flow is how. If anyone asks you the test flow after attending a workshop, you should be explaining in such. I am also providing a pictorial representation, right? With that also, you guys can explain. See, what I'm asking you is first the actual flow, how it starts is in the top module, we have something called run test inside an initial block. Inside that initial, the run test, we will be passing an argument, which is a test name. Now, just everyone hear it so that it will be useful for to you guys. This is a very important concept which you should all know. So, okay, inside this run test, we will be passing an argument called a test name. If the test name is not given from the command line argument, then by default, whatever test case is passed in this argument, that will run. Or if we have given some test case inside this run test, then whatever we are giving from the command line argument, that will override and that will run. So this is how it will work. So once the test is starts, then it will go and create the test, whatever test which we are mentioning, the test which will be extending from the UVM test. Then inside that the ENV gets created. So all these build phases come into the picture here because first the higher level component is created inside that, inside that, inside that. That's why our build phase is like top to down approach. So that's why the first test root, we also can say that this test is nothing but a root component. So because from this other components are getting created, that's why we call this test as a root component. Inside that we have an environment. Inside that we how many number of agents, those has to be created. Inside agent, if it is an active agent, the driver, monitor, sequencer has to be created. If it is a passive agent, only monitor has to be created. This way, if you explain anyone, they will know that, okay, you know phases also, you know the execution flow also, and you know what is the difference between active agent and passive agent also. This creates an impression to the interviewer that you know many of the things. In one question only, you should focus, express yourself in such a way that you know what all concepts, because you will not get more time to explain everything, right? So in one thing only, you should cover everything in brief. Then if the interviewer is interested to know regarding any one of the particular thing, they will ask you in detail. Then you have to explain that in detail. So this is how you have to explain anyone even in the interviews. Is it clear for everyone? Now you guys understood what is the test flow in the UVM test bench.
Yes.
Yes, ma'am.
And you guys should also know the difference between what is the question asked. If they have asked you the UVM test bench hierarchy, then you have to tell something different. When it is asked UVM test bench flow, now what I have mentioned, that has to be told. And if they ask you what is a driver and sequence handshaking, that you have to explain. And if they ask you to draw a UVM test bench architecture, then you have to explain this. So these are the different things. So don't mix it up with one another and don't mess your interview. So first you get an idea of each of the things. What is an architecture? What is the hierarchy? And what is the different phases? What are the different approaches are there in phases? What all kinds are there? Like functions, some are functions, one is task. So all these things you guys go through, and I have already provided the UVM interview handbook. So that also you guys go through. It is very neatly explained, and it is too good to learn such documents also. So just go through when you have so much content in your hands. Don't waste it. Just go through it and be clear with each and every concept. And if you don't understand it, you can come back to me. I will explain. That's not a problem. But I wish that everyone go through before we start any coding lab sessions, because this is important. If without knowing a theoretical knowledge, we cannot enter into the lab session. That's why the first 4 sessions are dedicated to the theory, right? If we still don't get it, and then there is no point. We would have directly started with the protocol itself, right? We have created a day-wise agenda to have a proper understanding and go in a systematic way. So just follow that and try to cover all the concepts, and we will meet in the next session. Okay. Is it clear for everyone?
Sure, ma'am.
Yeah. What about others?